Hey gang, this is Eric White. In this screencast, I introduce the various scenarios where it is useful to use Open XML to generate, modify, and query word processing ML documents. In other words, docx or docm documents. By scenarios, I mean the variety of application types where OpenXML can be a key component of the implementation of that particular variety of application. 95% of all OpenXML scenarios can be divided into one of 6 categories. There are 3 primary scenarios for word processing ML: docx generation, extracting content from docx files, and transforming docx to some other representation of that document. There are 2 primary scenarios for spreadsheet ML: XLSX generation and extracting content from an XLSX file. Mainly, there's only one scenario for presentation ML, which is PPTX generation. I'm not saying that there are not other uses for OpenXML. There certainly are, but 95% of all OpenXML applications fit into one of these 6 categories. Let's talk about word processing ML first, since word processing ML is the most used of the various markup languages. The first and most important scenario in word processing ML is document generation. Prior to OpenXML, developers often accomplished document generation by automating Word. Sometimes developers automated Word in server-side scenarios. There are technical challenges associated with automating Word in server-side scenarios. I've heard of customers who had a server room full of computers running VBA code to generate documents, but there are problems with automating Word in this scenario. If there is any problem, then Word may put up a modal dialog box, and you have no way to prevent Word from putting up such a modal dialog box from VBA or from a Visual Studio Tools for Office application that uses C# or VB.NET to access the primary interop assemblies. I've heard of customers who had an employee sit in the room watching various computers run their automation tasks so that if and when there were any problems associated with running those automation tasks, then the employee could stop the automation task, restart it, fix the problem, or what have you. It's interesting to read this knowledge base article around the issues associated with automating Office on the server. In contrast, doing document generation using OpenXML can be completely robust. The reason is that the only thing that's absolutely required to do OpenXML document generation is some kind of a library to work with zip files and some kind of a library to work with XML within those zip files. These are the types of libraries that servers are made of. There are rock-solid libraries both for handling zip files and for handling XML. Therefore, you can write document generation applications that can generate hundreds of thousands of documents with a completely predictable performance profile. The OpenXML SDK 2.0 was optimized for server-side scenarios. The engineers at Microsoft made sure that the SDK had predictable CPU and memory usage. One interesting approach to generating OpenXML word processing ML documents is presented on my blog at ericwhite.com. In this approach, you start with a template document. This template document has content controls in it. In those content controls, you put XPath expressions that specify where the data comes from that will replace those content controls. You also have as an input to this process an XML document that contains data that you are going to use to control the document generation process. In this particular case, there's an XML file that has a customer's root element. Underneath that root element, there are various customer elements. Underneath each customer element, there are orders. The template document and the XML data document are fed to the document generation process, which then generates multiple WordprocessingML documents. In the example program that I present in that blog post series, one of the examples is an example that generates a lot of sample data. I needed to generate a fair amount of random sample data so that I could see how this approach performed at scale. As delivered, this example program generate data generates an XML file with appropriate data in it. This XML file has 3,000 customers in it, and it has up to 3 line items in each order. First step is to compile and run the program that generates the sample data. We'll close that project. Let's take a quick look at the template document. One thing that makes it easier to look at content controls is to put Word into design mode. To do this, you click on the Developer tab and then you click on this button, Design Mode, and it then changes the appearance of content controls so that it has these start and end markers around each content control. Now let's open the document generator solution and let's run the example. This solution is generating 100 documents every single time it outputs one of these numbers. In this particular case, I haven't done anything to particularly optimize this. I've gotten far greater performance, for instance, by running this example on a solid state drive. That can always help. But as you can see, this example generated 3,000 documents in a very short amount of time. And here we can see all of the generated documents. If I look at one of these generated documents, I can see the data that was inserted into this generated document. You can find the blog post series here. Another approach is to use the Open XML SDK productivity tool. The productivity tool can take any Open XML document and generate the appropriate Open XML SDK code to generate that specific document. Having generated that code, it then is often a very straightforward process to go into that code and modify the code so that it uses some data source to generate multiple documents and to customize the generation of each one of those documents. I've covered the Open XML SDK productivity tool in detail in another video in this series. In that video, you can find out how to download, install, and use the productivity tool. You can find the table of contents to all the screencasts in this series at this location. Another tool that many developers find useful is the Document Builder class that is part of the Power Tools for OpenXML project. The Document Builder class enables you to grab pieces and parts of various OpenXML WordprocessingML documents and assemble them into a single document. Sometimes developers take an approach along the lines of generating small documents for each part of the composite document that they want to create, and then they use Document Builder to assemble all of those pieces into a complete document. At openxmldeveloper.org, there is a Document Builder Resource Center. You can find that here. There are a number of links to videos and articles in this Resource Center. If you're going to use Document Builder, it's important to come here and explore all of this content. Another important resource is the content browser on openxmldeveloper.org. Come to the front page of openxmldeveloper.org and you can find the content browser right here. You will find keywords that enable you to specify the type of content you want to find. So, for instance, if you're interested in docx generation, you can click this checkbox, and immediately upon clicking the checkbox, you'll see articles and screencasts listed down here. If you want to see the intersection of two keywords, just click them both, and then you'll find content that has both of those keywords. If you want to find only content that contains screencasts and videos, you can click that checkbox right there, and then you will see just those pieces of content that have screencasts or videos associated with them. The next important scenario around word processing ML is data and content extraction. There are a couple of interesting scenarios here. One is where you as a developer design a document that you send out to a number of users as a form. These users then fill in the form with the data appropriate to their particular situation. It might be an application for an insurance policy. It might be a survey for a club or organization that you belong to. Then, after all of the users have filled in their word processing document, they send it back to you. You then can write an Open XML program to extract that data from that word processing form and store that data into a database. Another interesting scenario around extracting content from an Open XML word processing ML document is that of validating code in word processing documents. Technical authors often write large documents that contain a lot of code. They may be writing this documentation or writing their book around a library that is changing underneath them. Maybe the library is under development as they speak. In any case, one of the last steps that many technical authors encounter is that of going through the entire book or going through their article and manually testing each and every snippet of code before they send it to the publishers. At least good technical authors do this. It's very frustrating to come across a code snippet in a book that doesn't compile or doesn't work as advertised. One approach is to put content controls in a word processing document and then put the actual code inside of those content controls and then have a system that extracts that code, compiles the code, runs the code, and then compares the output of the code to the output that is listed in their word processing document. To make this clear, I'm going to turn on design mode. Here we can see that there are content controls around the code here. There is some configuration information up here that tells what the ID of this particular test is. It also specifies an output ID. This 0001 out corresponds to this content control with a tag of 0001 out. When the automated testing system extracts this snippet and runs it, the expected output is this. When you run this example, it opens up those word processing documents, extracts all of those tests, runs all of the tests, collects the output, and then produces a report about the status of each one of those tests. At the beginning of this report, we can see that there were 7 tests with 24 snippets, and every one of the tests passed. The third common scenario around word processing ML is that of document transformation. As part of Power Tools for Open XML, I've written a class, HTML Converter, which performs a pretty high fidelity conversion of word processing ML to HTML that is formatted with CSS. In another screencast, which you can find at this link, I demonstrate a small ASP.NET web application that shows OpenXML functionality. Let's take a super quick look at that app. Here we're looking at the design mode of the web form that is in this application. Let's run this application. In this application, I can browse for an Open XML document. I can upload that document to the website. Let's display that document. This does a conversion of that document to HTML and then navigates to the page that has been generated using HTML converter. There's also a button here that appends Hello World to the end of the docx. If I display it again and go to the bottom, I see that Hello World that was just added to this document. This little example application also shows you how to download that modified document. I'll open it using Word, and we can see the Hello World that has been added to the end of this document. The screencast at this link walks step by step through creating this example. I've encountered several large companies that needed to build their own custom transformations of WordprocessingML to either some specialized dialect of XML or to some specialized form of HTML. One company was a large media outlet that required their authors to write their content in Word, and then they would do a very specialized transform of WordprocessingML to a dialect of XML that they would then transform further into various forms of HTML to be published on the web. In another case, there was a large software company that required technical writers to write in Word. There was then a fairly elaborate transform of that WordprocessingML to very specialized HTML for display on the web. So in this video, I've covered the three main scenarios around WordprocessingML. There are other scenarios, but you will find that 95% of all scenarios fit into one of these three categories. In the next video, I'm going to cover the various scenarios around SpreadsheetML and PresentationML.